Hi, good morning, afternoon, evening. Thank you for joining this session. We're in session 3B at the moment, and I am really excited to be moderating the session and to hear the presentations and to hear people's thoughts and views and questions on the papers. We connected these papers because it seemed like there was a similar thread running through them. And it continues from the discussion this morning. And this thread is that in some places, it doesn't seem that the market is doing, or at least it's yet doing, what it needs to in order to achieve Agenda 2030. And in that sense, the questions are when, how, why, should or must the state then intervene to get the market on track? And I think these papers pick up on those themes to different extents and looking in different contexts. So we have a really great paper, all really great papers, looking at decommissioning and recycling of solar panels, on the financing of renewable or the lock-in of carbon infrastructure in Africa, on the conservation, the role of the financial sector and financial services in conservation of nature and biodiversity in urban spaces, and also a bigger picture view on the role of modeling and the implications of uncertainty in setting policy. So with that short introduction, I will begin with the presentation. Just a couple of quick things. One, a reminder to please put your questions in the Q&A box, and it's also helpful if when you have a question that you you tag the presenter's name so that we know to which question which presentation your question relates. And then also, if you would maybe think about some key takeaways, and then at the end of the session, join a table, network with others, gather some of the insights that you had, that others who attended the session had, and post them in the chat. We are recording the chat, and it's really great for us, and I think for everybody, to see what are some of the takeaways that these papers have inspired? What are some of the questions that they raised? What is really kind of striking people? So it'd be really terrific if after the session you could join the table and continue the conversations with that assignment. So with that, why don't we turn it over to Carlos Vargas to kick off the presentations with his paper. Carlos, do you want to join us and start presenting?
Hello. Okay. Yes. Thank you. Thank you, Liz. So I'm Carlos Vargas. I'm professor for finance at Tec de Monterrey in Mexico, and I did this work jointly with professor at the University of Zurich. This is about recycling solar panels in the United States. So allow me to share my screen, and we can start with that because I think we have some limited time for this. The paper is called End-of-Life Decommissioning and Recycling of Solar Panels in the United States, a Real Options Analysis. Basically, the scope of the paper is provided that we had very good information about the United States at the time. And also, it was a very interesting scope of work to do because also the United States, it's precisely at the stage that these kind of decisions need to be taken. It might be interesting to see that perhaps, as Liz was mentioning, there's different actions we need to take. And if you think about it, this might be one of the actions that we would need to take at the end, because we are talking about recycling. But in reality, we've been so successful in installing panels in the United States that at the moment, this is actually something that it's becoming very, very relevant, and it's timely to just start thinking about it right now. So what's the problem here? We need to do something with those solar panels that have already been installed in the United States and the ones that will be installed in the next decade and so on. So those panels can be stored once they're useless. But at some point, those panels need to be recycled. This is very important, and this is the essence of the research presented here, because those panels cannot be legally disposed otherwise. They have to either be properly managed and recycled, or they have to be kept somewhere, because it's a pollution that it's not easy to handle. So the question here is when and where to start building those recycling facilities. At the moment, we don't have any. At the United States, we have one in France, for example, that was installed a couple years ago. And there's some actions starting to take place at the moment, but still it's very incipient, not only in the US, but all over the world. So the investment can be optimally delayed until it's possible to just avoid the storage cost so that the recycling becomes the optimal solution. That's basically what we try to optimize with this model. And there's, in our case, 4 proposals that we make on how this can be achieved. And we also have to choose one perspective, which in our case is the perspective of the US government in Washington. We understand this is complicated politically, but for the scope of our work, it was necessary to take a position. In this case, we see here, what is the problem here? We have in between somewhere 150,000 tons of waste will be produced and 600,000 tons of waste that will be produced just with the existing panels that we have today. This number continues to increase because solar panels become more popular, and I'll show you how in a moment. So basically what's been happening here, you can see the historical behavior of how those solar panels have been installed in the United States. That's the information we use for the study from 1999 to 2017. And we can see that just in the last 4 years of our study, 70% of the panels were installed. And also, those panels were installed mostly into certain areas. We can see here, for example, only Arizona and California, which is 2 out of the 50 states of the United States, they had installed 78% of the panels at that time. So we see a lot of concentration in this regard. So we also can expect that the next couple of years are going to be extremely important, as we can see here. Probably just until this year that we have the phenomenon of COVID-19 and all the economic effects that it brought. But in reality, we still expect that growth to continue in the next couple of years and decades. So we basically deployed a model that it's called real options assessment. And real options assessment, just to make it short, because it's not the purpose of the presentation, it's something that allows us to see the opportunity cost and not only incorporate the cost and the income that can be created with all of these, but also other factors that we can model and play with in our estimates. For this methodology, we take something that it's called a stopping time. And it's important to define what this is, because basically the stopping time tells us with incorporating tau into our modeling, the exact point where it's optimal to start working with this option. So basically the stopping time tells us when it actually should be working. The 4 options that we were considering here were a benchmark situation, which is basically to store the panels as long as possible, as long as it becomes financially inefficient. Then we had the first option is to install one centralized recycling plant in the United States. Option number B or 2, it's to install 2 regional facilities, not one big one, but actually distribute the recycling in 2 sites. The third option is just to do what Europe is starting to do at the moment, which is to use economies of scale and use existing recycling facilities for TVs and other electronics for recycling the panels, or option number D, which is to do exactly the same thing, but in Mexico, which would represent additional cost savings. For the literature, what I can tell you, it started to be seriously reviewed after the 2000s. Solar panels were not really an issue before the 2000s because they became economically viable and economically attractive just after the 2000s. It's mostly been done through time value of money, net present value, and it's a lot of technical studies, a lot of global research, but it was very incipient on research for the United States. And basically what we are doing is we're incorporating all of these modeling for a dynamic setting for the United States on one hand, but also incorporating the fact that real options are not typically used for choosing allocation of geographically where to establish those recycling plants in this case. And we not only work with time, but also with the location of these sites. Basically, we have here the basis of our model. As you can see here is a cost model. In order to make it a little bit easier and not get too much into the design, I try to label some of the components to give you an idea what we are doing. So basically, we have a storage cost, and we have how much supply of panels will be disposed every single year after some time. Once we have these bases, we start to make an income cost model for our panels, and we see that of course there's some cost embedded into doing all of these, but also there's some income that can be obtained from the panels. Once we have all of these modeled, we can also incorporate the distances that the panels would need to travel, either to be stored or to be recycled. In some cases, this could be a double cost because sometimes they can be stored somewhere and then recycled in a different place. But for the purpose of our model, as long as those panels had to travel outside of the state that they were basically installed, we would consider a cost for them. And then based on that, we can aggregate what's the benchmark situation, which is basically to store those panels as long as possible. Then we can do some investment for installing either solution that we are proposing. In this first case is one recycling facility, and we will choose also where it will be installed. And then we'll compare option A, which in this case is to recycle the panels or to keep them stored. We have to provide some storage cost in order to be able to assess how optimal it is, but it's possible to model in this setting. For our next model, we did a similar thing of what we had before, but we aggregated some of these economies of scale by distributing that into two facilities. It's a similar setting, but now we're incorporating another facility that will be taking part of those panels. And then for the one that it's on economies of scale, we basically need to incorporate savings, some cost savings by using existing facilities. And then obviously also for the initial investment that will be done for those panels, which is on the formula 4.14, we will basically reduce the investment because we will not do the whole investment for a new plant. We will just do an adaptation. And then the distance that the panels will need to travel for our last setting will include the distance to take them to Mexico because it's outside of the state as we were considering. And basically, what we observe here is that there's different places where those panels need to be installed. I try to go a little bit faster on the results, just not to run out of time. But basically, what's important here is out of the different options that we are proposing, we can see that some of those options are more optimal than others. Obviously, the easiest and the most possible to do at the moment is economies of scale, because that's the one that reduces most of the cost for the investment, and it's the one that becomes more attractive. On the second place, it's the one to take those panels to Mexico. If we can increase the savings, that can be reduced, but also the transportation cost makes it a little bit inefficient, but it's also possible to have it. And then the third option, new recycle facility, a centralized one, as we were proposing in option number A. And then the last likable option would be the one with two recycling facilities. What we also observe from our results is that still the investment can be delayed for almost, at this point, not so long, 14 years. It was from the start of our data set, but now 12 years that could be delayed still to make all the policy changes and everything that needs to be adjusted for that. But some locations like Arizona and California still seem to be the most attractive. And then we still have some important challenges financially, operationally, technically, and logistically to fix before this actually becomes a real problem. And I would like to conclude there. I hope it wasn't too summarized. I'm happy to answer any questions in the session afterwards.
Great, thank you very much. That was great, and thanks for sticking to time. Helen, can we turn to you now? Oh, sorry, Galina. Sorry, Galina, can we turn to you now?
Sure. Hello, everyone. Thank you, CrossFit 2020 and Columbia for inviting me to speak today. How